This is the Math 1111 Zoom meeting, week of 9th to the 13th, sections 4.3 and 4.4 this week. Section 4.3, page 387, practice problems. Section 4.4, 9 to 65. We'll have quiz 10 on Friday. Do Sunday, be over these problems. Web assigned problems for this week, section 4.3, 1, 2, 3, 4, 5, 6, and 8 only, and 1, 2, 3, and 4 only. And email me the percent of these 11 problems that you get correct. There's only one more week. Next week, we'll have our last test over chapter 4, and that will pretty much finish the semester, except for the final. And so we will give you an introduction here to 4.3 and 4.4. All right, 4.3. Is an intro to logarithmic functions. Basically, how do we undo E? Or in other words, solve e to the x, say, equals 3, and we want to find x. Now, you know, if you're going to have over here in scratch paper square root, if I wanted you to solve, say, x squared equals 9, you would undo with square root. So you do square root of x squared, square root of 9. On an equation, you get as square root of x squared undoes, and you would get plus or minus 3. And you could plug both in. 3 squared equals 9, and negative 3 equals 9. So both numbers work. All right. And so you're used to this. Functions that undo each other are paired on the same key. And so what happens is, if you come down to E above this ln, they're giving you the function that undoes E. What undoes E is an ln of x. Stands for the natural logarithm of x. So what this means a natural logarithm of e to the 2 must equal 2. We can punch this on the machine and show this. Hit ln, and then I hit second ln, which gives me the e of 2. And sure enough, I get 2. The ln and the e cancel, just like square root and x squared cancel. You can reverse the order and do e to the ln of 2. So punch the e first, then ln of 2, and you get 2. So the keys work in either order. In effect, these undo each other. Okay. The only other one on the calculator is base 10. if you'll notice, 10 to the x is above this LOG key. When they use LOG, they mean a logarithm of a base 10. So LOG undoes base 10. So I can go LOG of 10 to the second. LOG to the 2, and I get 2. These undo each other. In the reverse order, 10 to the LOG of 2, I can either hit, or I actually literally punch 10. LOG of 2, and I get 2. I can also literally punch it off the number, 10 raised to the LOG of 2. I didn't like that, rats. Sorry about that. Extra parentheses, apparently. Let's delete that, see if we get it. Yeah, you get it. So you can punch the 10 right off the keyboard, or you can use the 10 right here. You can do it either way. Okay. Base E and base 10 are the only bases the calculator Okay, so if I want to solve, for example, other bases or other bases, say I want to solve 2 to the x is equal to 16. You basically can do it in your head, or use your fingers. Two times 2 is 4, times 2 is 8, times 2 is 16. X must equal 4. 2 to the 4th equals 16. So other bases, they've got to be cooked. Now, to undo other bases, like 2, they write the base it undoes as a subscript. Meaning a log base, and they write a subscript 2. This undoes base 2 of 2 to the 4th must equal 4. These undo each other. You must believe, we can't punch this. You must believe this. We can't punch it right now. Okay. You can also go in the reverse order, 2 to a log base 2 of 4 must equal 4. Again, you must believe this. Okay, so if I have a 3 to a log base 3 of 10, it must equal, guess what? 10. Okay, hopefully with that kind of introduction, by the way, just give you the names of these forms, names of forms. If I have a E2 and E2, which you can punch this. This is called exponential form. And if I have an ln of e to the 2, this is logarithmic, and that equals 2. Logarithmic form. So the first of the homework will have you convert between these forms. All right, so let's try some examples here. First homework. Page 387. We'll start with number 7. Actually, let's see, number 7 to 47 odd, that's right. 7 to 47 odd. Okay. I'll give you a little table here. I don't know if I'll do them all, but I can show you. They start with a log base 8 of an 8 and tell you it's 1. All right, you see where the 1 comes from? The 1 is the exponent right up there. So these are undoing each other, get 1, and then they want an exponential form. All right, to get exponential form, you must undo. So you would go 8 to a log base 8 of 8 is equal to 8 to the 1. These undo and leave the 8, and you have 8 raised to the 1 equals 8. If you reverse this, 8 to the 1 equals 8. I know it seems strange when you first see it, but if you then fill in the table, number 7, log form, we'll call it. Log base, say this is what's given, equals 1, exponential form, 8 to the 1 equals 8. So that's what they want you to fill in. Log base 8 of 8 equals 1. And then here's what you fill in, 8 to the 1 equals 8. Notice how I went this base to that power equals this. That's kind of how to do it slickly. Try one more. Log base 8 of 64 equals 2. Do you see where they're getting that? That's log base 8 of 8 squared. 64 is 8 squared. So the exponential form would go base 8 raised to the second power must equal 64. That is the slick way. All right, this was given too over here. You found this. All right. Over on the next row, you have 8 to a 2/3 power is equal to 4. They want find log form. Well, again, you would undo log base 8 of 8 to a 2/3 is equal to log base 8 of 4. Taking the log base 8 of this side and the log base 8 of this side. These undo, and this says that the log base 8 of 4 is equal to 2/3. You have to check with the back of the book. At this point, can't really, there's no log base 8 on your calculator to punch this. So answer, log base 8 of 4 is equal to 2/3. So in your head, you're taking a log of this base of that, comes up this exponent. If you want to try one more, you were given 8 to the 3rd is equal to 512. Log form, you have a log of base 8 of the 512 is equal to 3. I don't know if that makes any sense to you all or not, but it makes perfect sense to me. Okay. Log base 8 of 512 would equal the exponent of 3. All right. Then in 9 to 16, they want you to find exponential forms. We'll try one like 9a is a log base 3 of 81 equals 4. 87, number 9a, a log base 3 of 81 equals 4. I could write out the steps. I don't know if that makes it more confusing or what, but exponential form would take this base raised to that power, comes up 81. That should be pretty obvious to you that this checks. This isn't because it's not on the calculator. But 3 to the 4th power is 3 times 3 times 3 times 3. Sure enough is 81. You get 9 times 9, which is 81. How about 11a? Log of base 8 of a 2 is equal to 1/3. Your exponential form would take 8 to a 1/3 power equals 2. You remember an 8 to a 1/3 power is a 3rd root of 8, and that does indeed equal 2. All right, if you go down to 17a, express in log form. You're given is equal to 10,000. Hope you know that's true. 10 times 10 times 10 times 10. That's 10 times 10. 100 times 100, you come up 10,000. The log form, you do an log of 10 to the 4th is equal to log of 10,000. Well, these undo each other, leaving the 4, and basically it's log 10,000 equals 4. You can almost check in your head, 10,000 is 10 to the 4th, log of 10 to the 4th would equal 4. You want to go in log of this base, 10,000 equals 4. Try 17b. Minus 2 would equal 1 over 25. You see where they're getting that? A 5 minus 2 is 1 over 5 squared, which is 1 over 25. You'd have a log of a base 5 of 1 over 25 would equal -2, the exponent. The logarithm is the exponent. All right, why don't we try evaluate some of these. Some of these are pretty easy, and some of these are a little trickier. Page 388, we're still on 4.3. Evaluate. 25a. A log base 2, like this read, log base 2 of 2 equals, well, base 2 there, what's the exponent? 1? The answer would be 1. B's undo, the answer is the exponent of 1 equals 1. All right. B, log base 5 of 1. See, I've got to get these bases, must match bases, must match bases. Well, 1 is easy. You'd go log of base 5 of 5 to the 0. This would equal 0. A log of 1 is always 0. How about C? Another trying to get an easy one. A log base 6 of a 6 to the 5th. Again, bases match. The logarithm is the exponent. 5. Boom, boom. You must believe this based on what we punched from ln and e and base 10 and log. If you want to see maybe a trickier one, try one like number 30. A log base 5 of 125. Okay, you must match the bases. Well, that's a log base 5, and 125 would be 5 times 5 is 25 times 5 is 125 would be 5 to the 3rd. And now it works exactly like these. 3. All right, how about B? Base 49 of a 7. Again, you must match the bases. And some of these get a little tricky. This hopefully was pretty obvious. 7 and 49. Gee, the 7 is the square root 49. So I could write this log base 49 of the square root of 49. Well, then a square root is a 1/2 power. A log base 49 of a 49 to 1/2 power. And now it works exactly like these. The answer is a 1/2, which again you must believe. How about 30C? Page 388. A log base 9 of the square root of 3. All right, well, this is a little tricky. How to get to 9? Again, the square root of 9 is equal to 3. So puzzling this out, if I did a square root of 3 here, I'd have a square root of the square root of 9. Well, that would be square root of a 9 to 1/2, and that would be 9 to 1/2 raised to 1/2. Well, when you raise, you multiply powers. So in effect, that's a 9 to a 1/4 is a square root of 3. So that's a log base 9 of a 9 to a 1/4. That'd be 1/4. It's a little tricky. All right, let's try 35. Part A, log base 4 of x is equal to 3. We want to solve x by undoing. base is 4, you have 4 to a log base 4 of x is equal to 4 to a third. These would undo. 4 to a third power, 64. You can almost check it in your head. 4 of 64, plug this back here, is a log base 4 of 4 to a third power. And sure enough is 3. That's the kind of thing they want you to do. Then down by 45, use a calculator. Evaluate log of 2. My apologies. So, this is not hard. And they want 4 places. Log 2. 0.3010, I guess, to 4 places. Notice, if I use ln of 2, 0.6931, completely different number. That's not the right number. And I have met people who get these things all confused. If you see log, then for God's sake, punch log. I don't want to insult your intelligence, but I've met people who punch ln no matter what it says. Okay, these people do not get good grades. Punch log if you see ln, punch ln. For God's sake, punch what you see. You have no idea how many people will just punch ln no matter what. Oh, really? I was supposed to punch. Okay. Rant is over. All right, let's see. Were there any other? We had 61 to 71. Ah, yes. Graphing these things, domain, range, and asymptote. And again, you don't have to starting from the graphs of this or whatever. By the way, log base 10 is log. I don't know why they throw log base. You can't enter log base 6. So I don't know why they throw that, but it's an even one anyway, so we won't mess with it. Let's oops, we're supposed to be on the, oh, wait a minute. You know, I shouldn't have thrown on 61 log base 5, log base 2. We'll do 65. If you're watching this, you can cross off. I didn't realize it had log base 5. 1 and 63. All right, 60, let's try 65. Graph h of x, ln of x plus 5. All right, let me compare it to a straight ln. In fact, graph ln of x. Make the point about it. E to the x. Let's show that. All right. Anybody remembers? It's got a y-intercept here. It's like your basic exponential. Approaches the x-axis as an asymptote. Notice domain. To infinity. Remember, exponentials have no domain problems. Range. 0 to infinity. Your horizontal asymptote, y equals 0. Okay. All right. ln of x know if you remember this property. Let's stick on y equals x to make the you see that? The y equals x line goes right through, and if you see the symmetry, the two curves are symmetric about the y equals x line, as they should be since they're inverses. Remember, f and f inverse are their graphs symmetric about y equals x. On a straight log, remember domain and range switch. Because you're switching TCH. Because you're switching step 2 to find the inverse, you switched x and y. So you switched input and output, which switches domain and range. So for log x, domain is 0, infinity, which you can see from the graph. You see how it approaches the y-axis 0, but never touches and goes to infinity. Range is negative infinity to infinity. It goes all the way down and all the way up to infinity. And the vertical asymptote is x equals 0. This is a vertical asymptote for log. All right, go on to log of x plus 5, and they're going to shift 65 graph log of x plus 5, and they're going to shift log of x left 5. Oops. Clear, clear, clear. We'll just stick on log ln of x plus 5. So yes, it has been shifted. The y-axis 5, it's going to cross at negative 4. Remember, straight log did this. You want it left 5. So the vertical asymptote went to x equals negative 5. Your x-intercept went to negative 4. Log of x plus 5. Domain. Starting from this vertical asymptote, it doesn't include it. That would be negative 5, comma, infinity. Range did not change. Negative infinity to infinity. It's still going all the way up to positive infinity. The vertical asymptote, x equals negative 5. That's the kind of stuff they want for graphs of logs. All right, let's switch on to section 4.4, see if we can give you a good introduction to 4.4. 4.4, 3 laws, logarithms. Page 390. May have seen this before. Try to explain this gibberish. Log of two things multiplied by a product can be busted up as a sum. Log base A of a B. I'll show you with numbers. So let's make it log of 5 times 3. And then I'll have log, this is base 10, understood. Just like a square root, they don't have to write a number with a square root. It's understood to be 2. Log is understood to be base 10. And add log of 3. See if this will convince you. Log, doing 5 times 3. 2 punch 15. 1.17609. And then if I punch log 5 and add log 3, there you are, 1.09. That's the first law. Log of a product a sum of logs. Number 2, take log base A and divide the A and B. You would take log base A of the top and subtract log base A of the bottom. Example, take an log of 5 divided by 3. That would take a log of 5 and subtract the log of 3. Five divided by 3, 0.2218. The other side, log of 5, subtract log of 3, 0.2218. All right, log of a quotient subtracts the logs. The most important, more generally, something on top has a positive log. As a positive log, something on bottom a negative log. Okay, keep this in mind. This will be really helpful when I give you some really complicated things and mix up the laws. Okay, and law 3, powers. Log base A of 5 to a third power is, say, I can use A's and B's, a 3 log base A, God, I'm butchering this, log base A of 5. So I could do, for an example, log of 5 to a third, 3 log of 5. Powers are coefficients. Coefficients are powers. Log of 5 raised to the third power, 2.0969. If I take 3 log 5, we have 2.0969. Okay. And the homework uses all 3 laws. See if I can give you an example from all the sections here. Page 395, number 9, say. Evaluate the expression. Log of 50, add log of 200. All right, I'm going to use law 1. And a log of an AB, log of A plus a log of B. So you see what happens matching this side to this. I can, if I have a log of 50 here, add a log of 200. See, this is my A, this is my B. On this side, I can write it as a product log of 50 times 200. Putting that together, I don't exactly know what 50 times 200 is. Probably should, but I don't. So quit. 50 times 200 is 10,000. Log of 10,000. And they want you to work that out. That would be a log of 10 to the 4th power. And that would be 4. And you can double check these things. Since it's LOG, you can punch it. You can go LOG 50 and add LOG 200. And there's your 4. All right. You start in with the algebra down around 23. Expand, it says. 23 is a log base 3 of an 8x. Well, again, it uses the similar log here. 2 pieces, A is like your 8, B is like your x. That would be a log base 3 of 8. Log base 3 of x. I want this simplified. Log base 3 of 2 to the 3rd is a log base plus x, and this would be a 3 of x. All right. 33 uses both laws. A log base 3 of a 2x divided by y. You would take a log base 3 of your 2x, put in parentheses, and subtract the log base 3 of y. And you want this expanded to add a log base 3 of x, subtract a log base 3 of y. Okay, 30, let's see, 30, how about 40, brings in all 3, something like 40. Log base A of an x squared over yz cubed. I want that expanded. You would take a log base A of x squared, subtract a log base A, what would you take a log of the top minus log of the bottom of yz cubed. Remember, powers are coefficients. So the 2 can come to the front. 2 log base A of x minus, and then a big parentheses because this can expand, log base, so we should have an A of y plus a log base A of z cubed. Well, then this distributes. 2 log base A of x minus log base A of y, and I'll put the 3 to the front, minus 3 log base A of z. Okay, in the next section, they want you to back it up and recover this. Notice, here's the thing to notice. A piece on bottom has a negative log. The y is on bottom. Y is on bottom. y bottom negative log. The z cubed is on bottom, negative log. The x squared on top, positive log. So if I want to go backwards, starting with 2 log base a of x minus log base minus 3 log base a of z, put the coefficients back up. Log base a x squared minus log base a of y base a of z to the third. And you'd have a log base a, put a fraction. If they're all positive, I don't need a fraction. They're all on top. There's no bottom. But any positive log goes up top. The negative pieces go on bottom. Why don't we try one like 49 then? Page 395. Log base 4 of a 6 plus twice log base 4 of a 7. Directions are to combine. You'd have a log base 4 of a 6 add log base 4 of a 7 squared. By putting this together, you'd have a log base 4 of 6 times 7 squared. See, there's no bottom. No negative log. Now, I don't know if they want us to go any further with this or not. That's basically 49 times 6. $294. I'm seriously doubting that there's anything you can simplify that out of strange. You have to have 4 to some power. 294. I don't think you're going to find it. Oh boy, it's going to kill that. Okay. The very last subject is called change of base. This is all the way to the end of 4.4, I'm sorry. 9 through 65. Basically 59 through 65. How do they want this to 6, that's pretty anal, 6 decimal places. Finally, how do we punch this log base 2 of 5? Let me show you something you can check an answer to give you some confidence in this. Base. All right. We said earlier that a log base 2 of 2 to the 4th, everybody believed was 4. These canceled. How do we punch this? Well, you'd have a log base 2 of 16 equals 4. Turns out we can punch it as log base 2, 16 is a log, use an ln of 16 and divide it by an ln of 2. So I'm going to punch it. If we don't get 4, I'll quit on the spot. ln 16 and divided by ln 2. There's our 4. This means all logarithms are ln if you divide the ln of the base. So in other words, 50 is 59, evaluate, log base 2 of a 5. Well, I can use ln of 5 if I divide by ln of 2. ln of 5 and divided by ln of 2. Make sure you close off your parentheses here. Very important you do that. 2.3219. Although they did say 6 places, 1, 2, 3, 4, 5, 6. Oh, that's pretty. I'd never ask you for 6 places. I don't know why or how they're getting so anal. You can check with the back of the book, and you can also believe, what we've shown you here. You can punch all logs as ln. By the way, this is how you graph. If I wanted to graph, say a log base 2 of x, which is not on the calculator, I would enter the y equals menu, ln of x divided by ln of 2. Think of this like a scaling factor. So it graphs just basically exactly like an ln, but it's scaled by ln of the base. So when I go and enter, I want to log base 2, I go ln of x and divided by ln of 2. And it looks pretty much exactly like your straight ln of x. It just got the same x-intercept. This is a log base 2 of x entered as ln of x divided by ln of 2. Yeah, they'll ask you for domain, range, and asymptote just to write them down. Domain, 0, infinity. Range, negative infinity, infinity. Vertical asymptote, x equals 0. So that is how you enter exactly other bases that are not on the calculator. All right, I hope that's a pretty good introduction to all the problems for this week. Hope you find it useful and helpful. And my mother is in the hospital. I've got to track her down, see if she's still there. If she's still there, I may wind up canceling the Zoom meeting tonight, but I'll send out a separate email notice. I'm not going to announce it canceled right now because she's supposed to go home today. She was supposed to go home yesterday. But somehow circumstances are conspiring to keep her there. So stay tuned. I will try to give as much notice as I can, whether I'm going to meet tonight at 9 or cancel tonight. All right, that's the 12 p.m. Zoom meeting. Thank you very much.